vector A in cylindrical coordinate system. So after simplifications, if you substitute this, do the simplifications, at the end you will get the answer minus 6 upon under root 40 a rho minus 38 divided by under root 40 a5. So we have expressed the vector A. We have expressed the vector A in cylindrical coordinate system. In cylindrical coordinate system. Same thing we have to do to express the vector A in spherical coordinate system. So the next target is we are trying to express the vector A in spherical coordinate system. A, R, theta and phi. Using the matrix relationship, we can convert a vector in Cartesian system to the spherical systems. So in matrix method, we may write this AR, A, theta and A phi component. This is the vector A in spherical coordinate systems, and we have to multiply this vector in sine theta, if you remember this. Otherwise you can also visualize this, as I already discussed in the previous class. Sine theta cos phi, then we have sin theta, sin phi, then we have cos theta. Here we have a Cartesian coordinate system. The ax component of the vector A is y, and y component of vector A is x plus z, and z component of vector A is 0. So if we are trying to calculate a theta component, then simply differentiate this equation with respect to theta, keeping phi constants. So derivative of cos theta is, the derivative of sin theta is cos theta. Then we have to keep cos phi c. Then derivative of again sin theta is cos theta. Then we have sin phi, and derivative of cos theta is minus sin theta. Then a phi component, differentiate this equations and eliminate the other variables. So here we get minus sin phi, then cos phi, and this will be 0. This will be 0. So you have to multiply this matrix, this 3 cross 3 matrix, with 3 cross 1 matrix. So the resultant will be 3 cross 1 matrix. So after multiplication, we will get AR component of vector A as y sin theta cos phi plus x plus z sin theta into sin phi plus 0. Then a theta component of vector A in spherical coordinate systems, then you have to multiply the second row with the column of Cartesian coordinate system. So you will get y cos theta cos phi plus x plus z cos theta sin phi. and this is 0. And at the end the phi component will be minus y sin phi plus x plus z cos phi. So the phi component is same as the previous value. The vector A is written as AR component AR unit vector along R, a phi component unit vector a theta component unit vector along theta, and a phi component of vector A and unit vector along phi directions. So with the help of this equations we can calculate the vector A, and this is equal to R if you look at this equations. Here the x, y, z are in Cartesian coordinate systems, are the variable used in Cartesian coordinate systems. So we have to eliminate or replace this value in terms of r, theta and phi. So using this relations we can calculate x is equal to r sin theta cos phi, y is equal to r sin theta sin phi, and z is equal to r cos theta. So you have to substitute the value of x, y, z in the above equations. So the vector A is r sin square theta. I am substituting the value of x, y and z in the above equations. Then you get r sin square sin phi cos phi plus r sin theta cos phi plus r cos theta multiplied by r sin theta sin phi. This is the AR component plus the phi component. So the phi component is r sin theta cos theta cos phi plus this term r sin theta. So sin theta cos phi plus cos theta into cos theta sin phi. This is the theta component of vector A, and the phi component is equal to plus r minus sin square phi into sin theta plus x plus z cos theta. So x plus z cos theta is this term sin theta cos phi plus cos theta into cos phi. This is the phi component. In this way we have expressed the vector A in spherical coordinate system. So the next target is we have to calculate the vector A at point P. So at point P, the value of r is 7, which we have calculated, and tan phi is equal to 6 by minus 2, that means minus 3, and tan theta is and tan theta is under root 40 by 3. So you have to calculate the value of cos phi, sin phi, then calculate the value of sin theta and cos theta. And the cos phi is minus 2 upon under root 40, sin phi is 6 upon under root 40, and sin theta is under root 40 by 7, and cos theta will be 3 by 7. Substitute all this value in this equations. Suppose this is equation A, then you will get the value of vector A at point P. In this way, we have expressed the point P in cylindrical coordinate system as well as in spherical coordinate system. Also, we have expressed the vector A, which is given in Cartesian coordinate system, in cylindrical coordinate systems as well as in spherical coordinate system. And we have calculated the value of A in 3 coordinate system at point P. So the next question is, express vector B, which is R 10 upon R AR plus R cos theta A theta plus A phi in Cartesian system and cylindrical system. After that, you have to find the value of B in Cartesian coordinate systems at point -340 and find the value of B in cylindrical system. That means phi pi by 2 and -2. At this point, you have to calculate the value of B. So this point is given in Cartesian system, and this point is given in cylindrical system. So you have to find the relationship between Cartesian systems, and this vector is given in spherical coordinate system. By seeing the expressions, you can decide that this vector is given in a spherical coordinate system. So first we have to convert the vector which is given in spherical coordinate system into Cartesian systems. Then